Okay, before we go through this video, we are truly grateful that we complete this assignment within the time given by our beloved lecturer. We cannot deny that completing this task will be almost impossible without the fantastic cooperation and dedication of our group members, Iman, Long and Aisyah. Moreover, we sincerely thank our lecturer of Calculus 1, Sir Syarul Heiry bin Yahya, in this section for the guidance and willingness to assist us with what we need to improve in this video content. Last but not least, we would like to express our gratitude to those who keep encouraging us to do this assignment directly or indirectly. In this video, we are going to talk about introduction, when to apply differentiation, related rates, problem statement, and the last one is conclusion.
What is differentiation? Differentiation is a method for determining a function derivative or rate of a change. The rate of change of function is defined as dy over dx equal to function x equal to y. When to apply differentiation? First, derivative of sum and difference. Second, derivative of product function, product rule. And third, derivative of rational function, equation rule. There is 5 applications of differentiation. First, related rate. Second, Rolle's theorem. Third, maximum and minimum problem. Fourth, determining increasing and decreasing function. Fifth, mean value theorem. The objective is to calculate the rate of change of one quantity in terms of the rate of change of another amount, which may be more easily to measure.
So next, we're going to do problem statement. Problem statement is a mathematical questions that given in a paragraph. So looking at the next slide, at this question, we can see it's a question about cylinder. A cylindrical can has a radius of r centimeters and height r plus 4 cm. When heated, is expanded at a constant rate of 5 cubic centimeter over second. Okay, so from this question, we got a hint of volume of cylinder is pi r2h. What to do when you got this kind of question? First, you need to do step A, which is show that the volume of the can is given by V. Okay, V equal to pi r3 plus 4 pi r2. And the second step is you going to solve B, which is how fast is the radius changing at the instant when the radius is 3 cm. Okay, moving to going to do step A, which is show that the volume of the can is given by V equal pi r3 plus 4 pi r2. First step, by using the volume of cylinder formula. The question is about cylinder, so we're going to use cylinder formula, which is V equal to pi r2h. Okay, so from the question is given radius is r cm, h is r plus 4 cm. So the next step, we plugging all the values provided into formula. Okay, V equal to pi r2. We insert the radius r, we insert the h, which is r plus 4. Then both of r and 4 will be expanded with pi r2. So the second step is B, which is how fast is the radius changing at the instant when the radius is 3 cm. So moving to the next slide, this is the final step to solving this problem statement question. So how fast is the radius changing at the instant when the radius is 3 cm? So the final step, we going to find how fast is the radius changing by using the information radius is 3 cm. Firstly, we need to identify what the question asks for. So we insert the formula of dr over dt equal dr over dv multiple with dv over dt. This is the formula that we're going to use in this step. And then next, we need to find dr over dv. Okay, so v is already given. V is equal pi r3 plus 4 pi r2. And then the next, we got dv over dr equal 3 pi r2 plus 8 pi r, and dr over dv we got equal 1 over parenthesis, we put parenthesis 3 pi r2 plus 8 pi r parenthesis. Okay, so we're going to sub all the information and solve it. Okay, so we start with dr over dt. Fill in all the information we got. So the equal is 5 over parenthesis 3 pi r2 plus 8 pi r parenthesis centimeter over second. And then we're going to fill in more information with dr over dt equal 5 over parenthesis 3 pi r. We're going to replace r with 3 and multiple it with 2. Okay, plus 8 pi r. We're going to replace r with 3 and put parenthesis, and don't forget to write centimeter over second. After that step, we're going to get the final answer of 0.0312 centimeter first over second.
Okay, for the conclusion, by implementing this differentiation method into this problem statement, we can conclude that the application of differentiation can be used to define the volume of volume, solve any other kind of problem, solve problem related to the value of a volume. Last but not least, how do we relate this application of differentiation in our daily life? First, manufacturing and packaging. Cans and bottles. In industry, metal cans or glass bottle expand when filled with hot liquid. Understanding how volume change help prevent overfilling or bursting. The second is cooking and kitchenware, pots and pans. When heated, the metal in the pot expand. Engineers use similar calculation to ensure that lids fit properly even when heated. And the last, construction and engineering, pipelines and tanks. Pipelines carrying hot fluids expand, so engineers use formulas like this to predict change in volume and avoid leaks or pressure build up. That's all from us. Thank you.